right here sits the best resin-based printer that I've ever used. Now, I've only used three. I've used the Elegoo Mars, the Photon Mono, and now the Photon Mono SE from Anycube, but this one by far is my favorite, for sure. The Photon Mono SE from Anycube is a $389 resin-based printer that's packed with features. At the heart of the system is a 6-inch monochrome LCD screen with a resolution of 2560 by 1620, which gives you a build volume of 130 by 78 by 160. Now that's a pretty standard build volume. It's pretty comparable to everything else that I've used. I think the Photon Mono is slightly larger, but it's not the build volume that makes me love this thing. It's all the other features that come in this printer. Wi-Fi, check. It's got an app, which is pretty cool. Easy bed leveling, internal activated carbon filtration, dual linear rails on the Z-axis. This printer is pretty solid and was noticeably quieter than all the other ones that I've used. And the monochrome screen was awesome because this thing really pushed out prints very quickly. Even the slicing software that Anycube sends with the Photon Mono SE isn't that bad. And that's what I had the most fears about, because I like to use ChichuBox, and unfortunately ChichuBox does not export the file type needed to print on the Mono SE from Anycube. So I had to use what they sent. In the past, I've always had mixed feelings about that. Like the Photon Mono, the software that came with that one was butts, and I thought this was going to be the same way, but luckily it's very similar to the ChichuBox software. So if you're used to ChichuBox, you'll be able to transition to the Anycube slicing software pretty easily and have great success. So, you know, after getting it out of the box, doing some test prints with what came on the card, just kind of feeling out the software, I knew I needed like a really good project to throw at this printer given its capabilities, to see, for one, if what I've been thinking about for quite a while was even possible, but if it was going to be possible on this printer. Now, the idea for this project came from kind of a bummer place. If you notice my system back here, I have just a standard hardline build in the 011 Dynamic XL from Lee & Lee, and on the front of it I have the giant EK distribution plate for this case that just looks awesome. It's got a pump built into it, it's got a flow meter in it. I just love how it, you know, manages all your runs and everything. I like it a lot personally, but the problem is that I got a very early unit from EK, and after a while I've noticed that there are some stress cracks starting to form in the acrylic, and they're quite scary. Now, if I didn't have a YouTube channel and EK hadn't sent this to me, I probably would have took this out immediately, because I know at some point the acrylic's going to give way and we're just going to have a mess and possibly some dead components. But in the interest of science, I think we should let it ride and see how long it lasts. See if it actually is a problem, see if they're just stress cracks, and if you leave them alone, they'll stay dormant, or if one day they just erupt in a volcano of sadness and just douse your whole computer. And I actually do have a way that I think I could maybe fix them, but it's one of those things that I know if I touch it, if I remove the fitting, it's just going to be done with. There's no going back. And I'm hopeful that if I leave it alone, I won't have any problems. But that got me thinking, it's too bad, man. If you bought one of those distribution plates, they're not cheap, and then you'd have like all these cracks in it. And I'm sure that EK, if you reached out to him, would replace it, no questions asked. But say they didn't, you would be out a hunk of change for a distro plate you couldn't use anymore. And I was like, man, it's too bad you can't print one. But can you? You might be able to. Obviously, you won't be able to print one that big, but you could print one like at least 120 millimeter size, like the kind that you see on the back of a case. And that's what we're going to try today to see if it works. Now, I know it won't work with FDM. That's obvious. FDM is not watertight, but resin printing might have a shot. So let me show you what we designed up over here. So this is the block that I ended up with. And it's quite simple, and we can back up to how this came to be, but when it comes to designing stuff, a distribution block is pretty straightforward. But let's go back to the beginning. So essentially, I started out with a square. Now I wanted this to be the same size as the rear fan of the exhaust mount on like a normal case, so 120 by 120, and I started out at 15 mils deep. To cut the channels, you just kind of think about how you want the water to flow through your block, and you just draw it out. And I just basically sketched up areas of where I wanted the water flow, and then I cut down 10 millimeters to get the depth I wanted and leave enough meat between the face and the internal cut to be thick enough that I was hoping you could still see into the block and it wouldn't crack or pose any issues. And how I got the block laid out essentially was the water is going to be coming in here, flowing up and over to the exit for the CPU back from the CPU to here, up and over to the top. This is where we're gonna exit to the radiator, back from the radiator up here, and then down and over, back to the pump. And after I had that cut how I wanted it, I just needed to put a lid on the situation. So that's kind of what I did here. If I turn this to transparent, you can see that I have 5 millimeters thick on the back and now 5 millimeters on the top, because this is essentially just a 5 millimeter extrude from the top of that cut up, giving us a total thickness now of 20 millimeters. So once I was at this point, I needed to make mounting holes to mount it to the actual case. So that's essentially what I did here. I did some countersunk M4 holes at the proper hole pattern for 120 millimeter fan, which is 105. Then I threw on some chamfers just to break that hard edge. And then I added these little 2 cuts here. So these cuts have a very specific function, and another chamfer just to match. They're going to be where we're going to put the RGB. Now this is going to mount in the case like so. And I already know that after printing this, it's not going to be as optically clear as acrylic. It's going to be a bit foggy because it's, it's a resin-based 3D printer. It's not going to be perfect. So I want to be able to light it up and hopefully illuminating the block itself. So at this point, now all we need to do is be able to get the fluid in and out of the block, and that's where cutting holes into the block comes in. So this is basically where our fittings are going to go for each of our runs. And the dimensions you're going to need if you're interested in doing this is 11.8 is what you want to cut your holes at. Then after that, after you cut your holes to that dimension, you're going to want to put a small chamfer on the edge there, just so when you start to thread in your fitting, it makes it a lot easier. So that's just, all this is a 0.5 millimeter chamfer at 45 degrees, and that'll get you a nice lead in for your threads. And then the threads are pretty straightforward. So just in case you're curious, this is the thread you're going to need for a fitting, for a standard, water cooling fitting that you'd use on 1013 EK tubing. So an inch tap is what you need to set it to. Start out like I did at 1/4 by 20, and then change the pitch to 1.337, and that'll get you the pitch you need to match up with that G 1/4 fitting. And that's it. That's really all there is to it, to this block. Printing it out, pretty simple. And the hope is that since there's not much to it, it's just a square, I'm going to be able to print this without support. So let's see how it turns out. It turned out perfect. I really couldn't expect better than what it did. The only gripe I have is that the clear, transparent resin that I used kind of yellowed during the process, but you can still see the channels where the fluid flows. The holes for the mounting came out perfect. The face is nice and smooth. The biggest concern I had was the tapped holes for the fitting, because if they're not perfect, well, it's not gonna work. And if you print something like this with tapped holes, they're almost always gonna come out good on a resin printer as long as you got your dimensions right. The problem that I've run into in the past is that when you print like this, like I did with this block, if the build plate is not 100% located, or it kind of wobbles a little bit, you'll kind of get like an ovaling of the holes, and then you never get a good fit. You can never screw the fittings in, and even if you can, they leak and they're just not perfect. But this thing, man, those dual Z-axis linear rails came in clutch, because this thing is rock solid when it prints. You could not tell the difference between the fitment of this hole, screwing this fitting into it, and then one you would just tap into a piece of acrylic. It was literally perfect. I was blown away by that. Most importantly though, the channel for the RGB came out awesome. The RGB fits in there perfectly. I used a little bit of gaff tape around the edges to give it a nice satin finish, and it kind of ties it together pretty well. The question is how bright is it going to be? It should turn out pretty good. Even though this is not super clear, it should soften that light coming out of those RGB strips up a little bit and actually make it look pretty good. Let's see. Oh, that's awesome. So I only put it on this 2 edges because this is where it's going to be mounted in the case, and I didn't want to really look at the LED diodes. I guess you could put it all the way around if you want, but that looks awesome. I couldn't be happier with that situation. Now, does it work? I don't know. It looks the part, but does it play the part? Let's hook it up. Eesh. So right now we're actually looking at the back side of the distribution block, and I want to watch it from here just so we can see the water flow through the channels of the block, because I think it'll look really cool. And then obviously we'll check the fittings to make sure they're not leaking. So, oh, you can see it moving in there just by me pouring it in the reservoir. Okay, we're gonna plug it in, hope for the best. That's so cool. The RGB looks actually really, really good. Pretty proud of this little 3D printed block. So far, so good. I don't see any signs of leaking yet. So this has actually been running for a minute now. And I don't want to be premature here, but I think a 3D printed distribution block is possible. As of now, there's no leaking. It's doing what it should do. It's distributing the water to the different components. It's doing it with RGB, which is the most important part. The only limiting factor really is the size of the resin printer. So if you had like a real big 200 millimeter tall or 250 millimeter tall resin printer, there's nothing stopping you from printing an entire front panel distribution block for your 11 Dynamic XL. I think we should put it in an actual PC just to see how, because I mean, we got humongous runs going everywhere. We know that it's not going to leak, at least right now. I think we should put it in a PC to see exactly how it looks when the runs are cut to length, because I think it'll look pretty good. So here is our guinea pig. It's a 3700X, 5700 XT inside this Antec case. And I'm hoping, I don't know exactly if it's going to fit, but I want to put the reservoir here, run one tubing up into the distribution block, then go obviously from the distribution block to the CPU and the radiator up top, back into the distribution block, back to the pump. And I'm hoping I can keep it nice and clean. The only issue is that this is a real computer that has real parts that work. And if we put it here and it fails, rest in peace 5700X. But I think it'll work. We still haven't leaked yet, and you gotta try, I guess. So let's take it apart and see if we can make it fit. So the original question was, can you 3D print a distribution block for custom water cooling? Answer is, yeah, you can. You can resin print it, can't FDM print it, but you can resin print a distribution block or plate, or I mean, it really could be any shape you want. It doesn't have to be a plate anymore. And it works actually really well. It doesn't leak. You use clear resin, you can get a nice RGB glow, and I think this actually turned out pretty good, especially for a case not really designed for custom water cooling. We kind of got the pump down here, but we got a nice line into the distribution plate, out and in from the CPU block, a nice little short run. And originally I wanted this radiator to be the other way around, so you could just do a short little in and out, but alignment wasn't there, so we had to flip it. But I actually don't mind it. It's kind of symmetrical. You got these long run, short run, long runs. So I really do like how it looks. I don't know how this would work long term. I'm sure we can find that out in the future, but this just opens up a whole new possibility of custom water cooling in the PC space for, you know, at least for this channel. Because this means that we can make a custom block or shape of any sorts to fit in any weird crevice of a case that we want to custom water cool. You don't got to worry about trying to fit. I mean, if you wanted to incorporate this pump into a block, I'm sure you could do it as long as you got your dimensioning right and your threads right, but I got so many more ideas. So thank you guys for watching. Hope you guys enjoyed this. This was actually awesome in my opinion, and it looked really cool. Until next time.